We have come across just now the chromophores. The chromophores is the unsaturated functional group that absorb in the UV visible region, and the electrons in this chromophores has low excitation energy and it is easily become excited. For the isochrome is the group of atoms such as OH, NH and halogen that is attached to the chromophores, and this isochrome will cause the normal chromophoric absorption to occur at longer wavelength or redshift. Okay, for the spectral change, okay, there are certain factors and terminology that related to the spectral change. Okay, this is your bit, let's say wavelength absorbance. Okay, for hypsochromic shift, the blue shift is the peak will shift to the shorter wavelength with shift here. Okay, and then the bathochromic shift or red shift is the peak will shift to longer wavelength here. For the hyperchromic shift, the peak will shift to greater absorbance, and basically this is due to the increase in molar absorptivity. A equal to molar absorptivity times B times C. Ingat tak? Beer's law. Okay, then the hypochromic shift is the shift to the lower absorbance. So this is related to the decrease in molar absorptivity. And one more thing, why the shift to shorter wavelength is called the blue shift, and the shift to the longer wavelength is called as red shift, because it is in the visible radiation, the visible light will produce from 400 to 700 plus nanometer. It will produce this color: violet, indigo, blue, green, yellow, orange and red. So that's why it is called blue and this is called red. And then for the hypochromic effect, the peak will, let's say if you add chromophores, you add double bond or triple bond to the compound, then it will cause move to higher absorbance, and vice versa lah. Kalau you remove chromophores, the peak will become shorter lah. Okay, for the bathochromic effect occur due to the addition of chromophores, addition of more double bond, let's say double bond or triple bond. Okay, if you add more double bond to the compound, it will increase, at the same time it will increase the conjugation. Conjugation is the alternate between single bond, double bond, single bond, double bond. And also the other factors is addition of isochrome and the solvent effect. So these factors will cause the bathochromic effect, and vice versa for hypsochromic effect. Okay, these terminologies. Okay, let's say effect of multichromophores on the absorption. Okay, the effect of more than one saturated bond, or such as there are 2 pi bond in the molecules, then this will cause bathochromic and hyperchromic effect. Will shift to longer wavelength, redshift, and it will increase, the peak will increase in intensity. The absorbance will increase. Okay, why? Because in conjugated chromophores, the pi star electron, the electron are delocalized over large number of atoms, and this will cause a decrease in energy of pi to pi star transition, and this will also increase in molar absorptivity. Why? Due to the probability of the transition. Okay, let's see here. Naphthalene, anthracene and tetracene. Okay, the addition of the chromophores, C double bond C, and this will cause the blue one, the spectrum is the blue one, cause it will shift to the longer wavelength, red shift, and at the same time the absorbance is higher. So this is the effect of multi-chromophores. The peak will shift to the higher wavelength, redshift or bathochromic shift, and it will the absorbance will become higher, or we call it as hyperchromic effect. Okay, the absorption by the organic species. Okay, the absorption of the inorganic species will involve the D and F electron. Okay, for the 3D and for the electrons is the first and second transition metal. Okay, this one you can refer to the periodic table here. 3D and 4D is from the transition element from here to here. 3D scandium to zinc and yttrium to cadmium.